The universe doesn't stop, it expands. Every second, every moment, the space between galaxies grows. Distances stretch, matter dilutes, and slowly, almost in silence, the cosmos moves towards its end. It won't be a sudden end. There won't be a final explosion or an immediate collapse. The end of the universe will be long, cold, and deeply lonely. But how does a universe die? Does it fade away slowly, or is it violently destroyed? Today, we live in a universe full of stars, galaxies, and light. But none of that is guaranteed forever. The laws of physics allow us to peer into the far future of the cosmos and pose several possibilities. Some are silent, and others terrifying. The question is simple but unsettling. Will be the final fate of the universe? Today, we live in a universe full of stars, galaxies, and light. But none of that is guaranteed forever. The laws of physics allow us to peer into the far future of the cosmos and pose several possibilities. Some are silent, others terrifying. The question is simple but unsettling. What will be the final fate of the universe? The universe has been expanding since the Big Bang, and as it expands, it becomes less dense. Stars are born when clouds of gas collapse under their own gravity. But if the gas disperses too much, star formation stops. That has already happened in many regions of the cosmos. Elliptical galaxies, for example, consumed all their gas billions of years ago. In them, stars are no longer born. Only small, reddish stars remain, red dwarfs that burn slowly for nearly 1 trillion years. But even they will one day go out. Spiral galaxies, like the Milky Way, still retain gas. The James Webb shows us regions where new stars continue to be born. But this stage will not last forever. In about 5 billion years, our gas will also run out. When that happens, the universe will stop creating stars. There will be no new lights, only ancient relics, slowly cooling in the darkness. Meanwhile, something even more unsettling is happening. The universe is not only expanding, it's expanding faster and faster. Distant galaxies move away until they cross an invisible boundary, the cosmic horizon. Beyond that point, their light will never be able to reach us. One by one, galaxies will disappear from the night sky. For future civilizations, the Milky Way will be the entire observable universe. Clues about the Big Bang, the expansion, and the origin of the cosmos will have vanished forever. The universe will erase its own history. But even after the stars die, the universe will not have ended. Black holes will remain. According to Stephen Hawking, black holes are not eternal. They slowly evaporate energy through a quantum process called Hawking radiation. The small ones will disappear first. Supermassive ones, like those at the heart of galaxies, will take about 1 followed by 100 zeros of years to fade away. It is a Google of years, a number so vast that it completely defies human imagination. And perhaps even before that, matter itself will disintegrate. Protons could decay. If that happens, all known matter will cease to exist. Nothing solid, nothing stable. This scenario has a name, the heat death of the universe, also called the Big Freeze. All energy disperses. The temperature approaches absolute zero. There are no longer thermal differences that allow work to be performed. The universe does not die with violence, but with a whisper. Dark, empty, frozen. A cosmos where nothing can happen. But there is another path, much more brutal. The expansion of the universe is driven by something we still do not fully understand. Dark energy. If this force continues to increase, the expansion could become unstoppable. First, galaxy clusters separate, then the galaxies. Then the stellar systems, until not even atoms can hold themselves together. This scenario is called the Big Rip, an end where the universe does not cool down but tears apart. Planets, stars, molecules, atoms, everything is destroyed. Even the fundamental forces could break. It would occur in about 10,000 trillion years, or 10 sextillion years, long before the evaporation of black holes. It is the most violent end imaginable, and yet we do not know if it is real. There is a third possibility, much more speculative. What if the expansion stopped? What if the universe began to contract? This scenario is the Big Crunch, or more precisely, the Big Squeeze. The universe would become increasingly hot and dense until it collapses into a singularity. Some quantum models suggest that a new Big Bang could be born from there, one universe after another, an eternal cycle. But today, the evidence doesn't support this idea. All these endings occur on inconceivable timescales, trillions and trillions of years. And yet, our civilization faces immediate dangers: climate change, pandemics, misinformation, irreversible decisions. The universe can wait, the Earth cannot. Perhaps the greatest lesson of the end of the cosmos isn't about the distant future, but about the responsibility we have today. The universe will one day die. That seems inevitable. The exact way, not yet. But as long as time exists, as long as there are stars in the sky, human curiosity will remain alive. Because understanding the end is also a way of understanding our place in the whole. And as always, let's keep looking up.